Now we look at writing a polynomial in descending order and factoring out the greatest common factor, also commonly called the GCF. Okay? So first, let's talk about writing a polynomial in descending order. So before we ever try to factor a polynomial, it is often useful to write it in standard form first. Not standard form, sorry, in descending order first. So it's important to know what descending order. I do believe that this is probably one of the most overlooked pieces in factoring. Okay, if you miss this, it can make the factoring much more difficult or even impossible to finish in some cases. So let's see an example. So I've given 3 polynomials here, and our task would be to write them in descending order. Now the first polynomial I've given has 4 terms, and it is already in descending order. Now what does that mean? It means that the powers on your variables decrease. So you've got x to the third, followed by x squared, x to the first here, and then here you have x to the 0 because there is no x. So when I say descending order, it means the degree of the terms descends. Okay, so that's what descending order means. Now if I look at the second polynomial, it's 2 terms. It's a binomial because it has 2 terms. It's not in descending order because you've got your a to the first term before your a to the second term. So what we have to do is write this in a different order. So we need to put the a squared term first. So we have positive 4a squared, and then we have to write the negative 6a to the first term next. So now we've got the squared term first and the first power term second, and that's in descending order. Again, I'm not talking about how to factor yet, I'm just talking about how to write polynomials in descending order because you want them in that order before you try to factor. Now the third polynomial is also not in descending order. So the highest power term is the x to the 7th term. So I write negative 3 x to the 7th, and then the next highest power is the x to the 6th term. So plus 12 x to the 6th. And finally, the last term is x to the 4th term, which is positive. So I have positive, or plus, x to the 4th. And now these are all in descending order. Now let's move on to the GCF piece of this video. So that's descending order. Let's go and talk about the GCF. And before we do that, we have to first recall how to distribute. I'm not going to spend much time on this because it's pretty simple, but if I have 2x times the quantity 5x minus 1, to distribute or simplify, meaning get rid of parentheses, you would distribute the 2x to the 5x and to the negative 1. In other words, the 2x will multiply by each of those, giving us 10x squared minus 2x. Okay, so this is how to distribute. All right. What we do is, if we want to factor out the GCF, let's start with a simplified polynomial such as 10x squared minus 2x. What you're trying to do when you factor out the GCF is you're reversing the distribution process. So you reverse distribute. So instead of multiplying something into this, you're trying to figure out what you can take out, what will divide out evenly. And what we notice is that 2x divides evenly into both terms. It's actually the biggest thing that divides evenly into both terms, 10x squared and negative 2x. So what we do is we factor out the 2x. So this equals, I'll put my 2x here, And when I factor it out, so what we're doing, so factor out or divide out is really what you're doing. Because when you distribute, you multiply. When you factor, you're dividing it out. So we divide out the 2x. So if I take 2x and divide it from 10x squared, that gives me 5x. Because 2x times 5x equals 10x squared. And then if I divide negative 2x by 2x, I get negative 1. Because 2x times negative 1 equals negative 2x. So factoring out a GCF is simply trying to determine what you can divide out of every term evenly, and then figuring out what's left so that if you were to distribute that, you'd get back what you started with, because the two polynomials here have to be equal to each other. So this is the original polynomial 10x squared minus 2x in a factored form, because it's a product, it's multiplication. Now let's go back to our original three polynomials up here and talk about how they factor. So let me clean this up a bit. Okay, so I've recopied them here, cleaned it up a bit. Let's look at this first polynomial. Actually, let me stack these on top of each other. I usually work math problems vertically, not horizontally, so let me rearrange these again. Okay, so we have each of the three polynomials in descending order first, and we're trying to factor these. So this first polynomial, what I'm doing is looking for anything that divides into 4x cubed, 6x squared, 2x, and 8. And I want the biggest thing that divides in. Well, I can already see that 2 goes into 4, 6, 2, and 8, and that's the biggest number that divides into all four. So I will copy my 2 down here. And then I look at the x's. Since x does not divide into 8, I cannot factor an x out. There's no common factor of x to all four of these. Now the first three terms have a common factor of x, but the last term does not. So my GCF, my greatest common factor, the biggest factor that's common to all of these, is 2. So then I have to figure out what's left if I factor it out, if I divide it out from each term. So I should have 4 terms left inside the parentheses, so that if I distribute my 2 back through, I should end up with this answer, my original problem. So if I factor out my 2, from 4x cubed, I get 2x cubed, because 2 times 2x cubed is 4x cubed. If I factor out my 2 from negative 6x squared, that leaves me negative 3x squared, because 2 times negative 3x squared is negative 6x squared. And similarly, if I factor a 2 out from 2x, I get positive x, because 2 times x is 2x. And if I factor out a 2 from 8, I get positive 4, because 2 times 4 is 8. And now it's factored because I have a product. All right, next one. I look at 4a squared and negative 6a and figure out what they have in common, what divides into both of those evenly. And again, I can see that 2 goes into 4 and 6. But now I can also see that a divides into a and a squared. So I pull the a out as well. And then I have to figure out what's left. And the result that's left is going to be a binomial, 2 terms, because if I distribute 2a, I should get back 4a squared minus 6a. So if I divide 2a out from 4a squared, that leaves a 2a, because 2a times 2a is 4a squared. If I divide 2a out from negative 6a, that leaves me negative 3, because 2a times negative 3 is negative 6a. And now this guy is factored as well. All right, finally, the last one. I'll move a little quicker, but there's one thing to notice here. I notice that my first term here is negative. Anytime the first term is negative, and it's called the leading term, if the leading term is negative, after writing in descending order, make sure to factor out Not the GCF, but the negative GCF. So in other words, you're going to factor the negative out with the GCF. So when I look at negative 3x to the 7th, 12x to the 6th, and x to the 4th, there's no number that divides evenly into all those except for 1. Now I could write a 1 down if I like. And I'm going to factor the negative out also, so I could write negative 1. And then I look at the x's and I see that x to the 4th divides evenly into x to the 4th, x to the 6th, and x to the 7th. So I'm going to factor out negative 1 x to the 4th. Now notice that's the same thing as just negative x to the 4th. So that's typically how it would be written. So if I factor a negative x to the 4th out from negative 3x to the 7th, that's going to give me 3x cubed, because negative 1x to the 4th times 3x to the cube to the 3rd gives me negative 3x to the 7th, which is what I need. All right, then if I factor negative 1x to the 4th from positive 12x to the 6th, that's going to give me negative 12x squared, because negative 1x to the 4th times negative 12x squared is positive 12x to the 6th. And finally, if I factor negative 1x to the 4th from positive 1x to the 4th, that simply leaves me with negative 1, because negative 1x to the 4th times negative 1 gives me positive 1x to the 4th. So what you notice here is if you factor a negative out, the signs in here change. So up here you had negative 3, and down here you have positive 3. Up here you have positive, and down here you have negative. And finally up here you had positive, and down here you have negative. So this is our factored form of that original polynomial, x to the 4th minus 3x to the 7th plus 12x to the 6th. And when you factor out a negative, all the signs in the parentheses change. You don't have to remember that, it just makes sense. Because when you factor a negative out of a negative, you're left with a positive. If you factor a negative out of a positive, you're left with a negative. And that's how to factor out a GCF.